I need help.
I guarantee you today someone will say, why didn't you show that to us in grade 11? Because you have to. And you are way wiser than you were in grade 11. If I showed this to you in grade 11, your heads would explode, you'd all run to the door, and I'd have nobody left in class, and I'd lose my job.
It's just gone.
Okay. So, follow along with me. You'll probably want to take some notes. At one point in time, I had a handout for this, but it never really worked very well. So I'm going to just let you do the old blank loose leaf kind of thing today. So gather up what you need, probably loose leaf, probably a pencil. Some things need to be written down, others don't. Remember, it's about can you learn something. Sometimes just the simple act of writing it down helps you learn it, right? All right, so do you remember this from grade 11?
Yeah.
I don't.
The plane flying in the wind. The one on the left, which way is the wind going, the one on the left?
With it, yeah.
With it. This one here, the plane, the wind is against it, and here it's sideways.
Right.
Exactly. Okay, good. Okay, so in grade 11, we added two types of vectors. This is just reminding you don't need to write any of this down. Okay? We did vectors at right angles to each other, and we used our friend Pythagoras. And they mentioned Pythagoras in the video, right?
Yeah.
Pythagoras was the guy, and his followers, the Pythagorums, right? I think that's what they refer to as. You know, a squared plus b squared equals c squared, right? And they were a group. They believed in that perfect universe of nice numbers, and they didn't like it when they got irrational numbers. Like pi. Ooh, pi was probably illegal in the Pythagorean world.
Probably.
Very evil. Okay, then we also did vectors not at right angles to each other, and you had to use a ruler and a protractor. And sometimes we were a little bit off, but for the most part, you guys did pretty good. Okay, so I'm going to take that off the table and show you a more mathematical way to do it. And I've been laying the foundations for this in grade 11, you just haven't realized it. Kind of used it? Okay. Watch and see what happens here. No, just don't freak out. Don't freak out.
Are you sure?
Okay, I got vector A right here, and I got vector B. Now you'll notice vectors and coordinate geometry are actually quite a bit related. And here's where they're going to actually meet. Okay? So this vector here, vector A, can I make that a bit bigger? Yes, I can. This vector A here can also be known as 7, 4, because it's a vector that joins 0, 0 to 7.4, right? So it's just another way of describing a vector position, right? Now, if I were to add them together, I should take that green one there. I don't think I can do it. Let me just do it like this. I can do that, and normally we would do this kind of thing, head to tail, right? And then we would go like that. And now some books talk about the parallelogram method, and that's all fine and dandy. Okay, but watch this here. So there's vector A. There's vector B. It's going to put it tip to tail. Right? Now, what's the x value here to A? 7. And then what was the x factor on B? 5. And 7 plus 5 is? So what I did was I just added the x, and then did the same thing work for the y?
Yep.
4 and 14, 18, right? So these are called the x components and the y components. Do you remember doing, and I changed my terminology, do you remember doing, what have I got next? Oh yeah, there it is right there. Perfect. Jeez, I'm smart. Do you remember doing FAX and FAY?
Yes. I hate them.
I was setting the foundation for this because the FAX is the x component of the applied force, right? The x component of the applied force, which is really, if you go back to here, like let's look at the 7 and 4, right? So if this is a certain length, and that is 7, 4, what's the FAX? 7. What's the FAY? 4. But I'm not going to give you those. I'm just going to give you what this length is, right? And what that angle is. That's how we deal with vectors, right? So how can I get FAX from FA and the angle? Well, think about trigonometry. FAX is adjacent, so FAX, and I think I taught you this in grade 11, is going to be FA, what is it? Yeah, cos theta. And FAY is going to be FA sine theta. Is that something that you think you should write down? AJ believes so, he's already started.
AJ.
Right here. All I really got to do is show you. I showed you just now how to find the x and the y, but I haven't really shown you how to sort of put it all together to add the x and the y. But really, that's what you're going to do. Okay? So, well, here's another one. Watch this. This is cool. So we're going to take A. Where shall I add it from? Let's go from right here. So there's vector A. And there's vector B. And there's vector C. Now, if I show the components of A, B, and C, so that means that the resultant is where? From there to there, right? Okay, now if I show the components, and if I take, let's start from, doesn't matter where I start from, there's AX, I'm going to add AX, and I'm going to add it to BX, I'm going to add up all the X's. Now this X is actually negative, so now where does it go? Still tip the tail though, right? So like right about there, right? Okay, then what would you call this little bit right here? The x of the resultant, right? Is that what you meant? So like Rx type? Yeah? Okay, and then I'm going to take the AY, and it doesn't matter where, why won't you go over there? Okay, well, there I guess. AY, we're going to add BY and CY, and what would you call the sum of all those?
Wait, why can't...
You'd call that RY, right? That would be like that there. And now if you take RX and RY,
Oh my god.
gives you a right triangle.
why is it, yes, you get to use, oh, that neat thing? Yeah, not exactly. But what is the advantage to putting it as a right triangle?
Gives you...
Exactly, you can use Pythagoras. You don't have to use a ruler, you don't have to use a protractor. So it is pretty neat, right? What steps did we do? We found the x components, added them together. We found the y components, added them together, and then we took the rx and the ry and added them together and found our
Do we have a little
r. You don't have this, but we can do this all mathematically, which is what I'm going to show you today. Okay, so do you see the steps, what we have to do?
Yeah.
Okay. See, I knew someone was going to ask that.
She
You know
said
what
it was
though, I
gonna be
like the way
good.
we learned it first.
Did you?
It was like the baby step in.
I don't you try to tell me, if you saw that in grade 11, that you wouldn't just say, I don't know.
Well, I seen it in grade 11.
If you
and
explained
someone
it
else was there.
more in depth when we were in grade
Yeah, but you were a year younger.
It's like you're learning like grade 12 math and kindergarten.
Plus, you, like I said, you get to feel like part of an exclusive club, right? Like those. Forget that. We know how to do it the real way.
Yeah, cool.
All right, so here's how this example is going to work. I would suggest you write this example down, and then we're going to do it together. Okay? So I'm going to give you a chance to write that down. You don't necessarily need to draw these. Just write this part, okay? Just write that part. We'll do each one of those individually. Okay, so what are the steps? The first thing we did was find the x's and the y's. Would it be okay if we found the x and the y's of D1, the x and then the y's of D2, and then the x and the y's of then of D3? Would that be okay? Like, I don't have to do it all x's first, right?
No.
Okay. So, D1 is 0.5 kilometers at north, 20 east. Now remember in grade 11 too, you were still learning about that direction stuff, right? So this one here, D1, don't write this down yet, right? So there's your components. This is going to be D1x and this is going to be D1y. Are they always going to be, are the x and the y always going to be perpendicular to each other?
No.
They have to be. The x means horizontal. The y means vertical. They will always be 90 degrees to each other. Okay, so there I've drawn it. D1 was 0.5, right? Right? D1 was 0.5, and the angle here was 20. So D1x is going to be opposite. You can draw it now. And I'm going to go like this. Right? Yeah, let's always pause there for a second.
I'm confused.
I'm going to go back to, hang on, I want to do this. That's what I told you, right? I said that D1 just stands for displacement 1, vector 1, whatever. I'm making it very simple to begin with. Vector 1 is 0.5 kilometers at north 20 east. That's what it looks like there, right?
Mm-hmm.
Okay. Now, in this situation, the x is actually opposite the 20, so the x is going to be the sine of the cos. The x is opposite,
Sine.
so it's going to be the sine, right? Is the x always going to be the sine?
No.
No. It's not. So you have to sort of watch. Here the x is opposite, so it's sine. So I'm going to write d1x is going to be equal to 0.5 sine 20 or 0.17. And that is to the right. So then the value should be positive. Okay, I'm trying to go slow here.
See, we should have done this yesterday.
Why? D1x is positive. Now how do I find D1y? Do the same thing, but you just use cos, right? D1y is 0.5 cos 20. I like to set it up so I got my x's in one column and my y's in the next column. Okay, you sort of continue that. And then you can sort of add vertically after. Kind of makes a nice visual. Okay, so I found the x and the y component of vector 1. Now I just do it again for vector 2. Vector 2 was... Did I go too fast? Did I go too fast? The question was, why is that negative? If I go back to one of these guys, and instead of going like right, I actually go, I can't make it go right, but if I went the opposite direction, it'd all be wrong, wouldn't it? Right?
This
Yeah.
one made more sense.
So you have to absolutely make sure your directions are right. Take your time, nice and neat, spacing, use a pencil.
Oh, well, that sucks.
So north.
Oh, sorry, I kind of blacked out there for a second staring at someone. I didn't mean to do that.
North and west are negative. Or even south.
Oh, was that out loud? Here's how you do D3. Sorry, AJ, I'm going to have to call you on it. Pencil, my friend. Excellent. Okay, D3. This is D3. It's 0.8. So this one here is D3x, and this is going to be D3y, right? There is no arrow. Excellent question. I messed up. Yes, there should be arrows, shouldn't there? Yes, there should be.
That's like one thing you want.
There should be. So D3x is to the left, so it's actually going to be negative. Now, is it automatically going to become negative? Like when you go 0.8 cos 50 on your calculator, does it come out negative?
No.
No.
No, it does not. You have to know to make it negative.
So south and west are
South and west are negative,
negative.
right? You have to make it negative. Slow down, take your time.
But you don't put the negative in when you're doing that.
No, you go 0.8 times cos 50, and then you say, and it's to the left, so it's minus 0.51. Okay?
I'm going to mess up on that one.
Fortunately, I will follow through on your work. But it's got to be, organized, so I can do that, right? I got to see that you know the steps. If the steps are there, you're going to get like 4 or 5 out of 6. Okay. Do it for y. 0.8 sine 50. Minus 0.61. Why minus? Because it's down.
Down.
Down. Well, I know. You should, but I'm more about the process as opposed to the details. Okay, so in a sort of graphical, visual kind of way, we have now gotten to the point where I've pulled out all the AXs and all the sorry, the AX, the BX, the CX, and the AY, the BY, the CY. Then what did I do here? I added them by placing them tip to tail, right? But because they are now numbers, they're not vectors, they are scalars, I can just do what? Add them together. So you literally just add the x's together. Now that looks really complicated, but let me just go through it because it's not that bad.
Okay.
Right? The Rx, now you probably have a nice column of numbers, your x is down the left side, right? Your y is down the right side, right? So I usually just draw a line, kind of like you're adding up numbers, right? Because that's what you're doing, right? And then underneath you're going to write Rx, which is the x component, like I should really have. Can I do this? No, I can't. Rats. You're going to have on the left-hand side, and you don't necessarily have to have that step, but you need to write Rx is the x component of 1, the x component of 2, plus the x component of 3, and then you simply add them together. That make sense? Add all of the x's together. And again, you should probably have them in a column.
I'll do that next time.
Right? It is nice to keep them in the column.
Call who?
Then what's the next step? Same thing for the y's. Same thing for the y's. So ry, y resultant, y component of r is d1y plus d2y plus d3y, and then you add the y's together, and you get some number. Okay, so I've added the x's, I've added the y's, so from a visual standpoint, I've now put them all lined up together like this, right? And then I actually have to do what? Combine the Rx and the Ry to get my final result. So how do I do that sort of in an algebraic standpoint? Exactly, right? I've got to go Rx squared. Well, should you draw the picture, do you think? Do you have to draw the picture?
Don't try.
Well, most students find they need to get going, right? Don't feel, if I was doing it, I would do it, but that's because I've done it for kids that way all along. That's just a habit for me. If you feel eventually you can do it without, go right ahead. But for most people, they just get a sense of, I need to do this so I get it clear in my head, right? So the Rx is negative, the Ry is, and you really, I mean, you have to know the angle here, right? So it probably should drop. Because it's a vector. Always got to have the angle. Oh, it's just tan, opposite second bunch tan makes. Okay. Can you solve it the rest of the way, you think?
No.
Should be, yeah, you should be able to. You're going to go, this is R, Pirate's favorite letter.
It's actually C.
Instead of
Oh,
C.
really loves the C. Got me. All right, so there it is there. You don't have to redraw it, obviously. So you're going to go, oh.
Whoa.
Oh my gosh.
I can't do
Now-
that. I don't.
That is way more work than you need to show, but some people like to see all the steps. So just for those people, I've shown it all. So R squared is Rx squared plus Ry squared. The Rx is the minus 0.64 squared. Does it have to be negative in there?
No.
Yes.
Doesn't really matter, right? It's going to be positive. You should, just to be correct, you should. The Ry is the minus 0.14 squared, and you get 0.66 kilometers.
Which direction?
We haven't finished. We know that it's down to the left, right?
So it's going to be
So it's going to be, this is actually going to be west, and then south, right? West, some number south. How do I find that some number? The angle, the theta. Is it always going to be tan, Brett?
Yes.
Yeah.
Yep, totally.
No.
You could see it.
All sorts of answers.
Always have the same two.
Always going to have the same two, which are always going to be the opposite and the adjacent. Always can. Makes it nice and simple. Because the other two have the what in it? hypotenuse. I mean, you could, I guess. You could do this. You could put the 6.66 in there and then use sine or cos if you wanted, but why would you? Just use the ones that you already got. So it's always going to be tan. Remember, opposite, adjacent.
Hang on 1 second.
I'll slow down. Yeah.
Need to go to the next page.
Okay.
Wait, hold on.
Make sure your calculator's in degrees. Those of you that are in pre-calc math might be in radians. You don't want to be that. You don't want to be in gradients either. You haven't graduated yet. Don't want to be a grad on your calculator. Hey, you know what? This is like the. This is. I guess just pause here a second.
See what's the answer.
12 degrees.
So you don't.
Yeah, you know what? I'm getting more and more into just leaving the angle as a whole number. Now, is that completely done? No, I still got to write west 12 south. Okay. Now, what makes this question?
Why did you have to find a 0.66?
Well, you got to know how long it is. Remember, every vector has two parts. It's how long it is and the angle, right? Now,
Just like that one.
what makes this? I mean, it seemed kind of complicated. It seemed long, but remember, excuse me. How many did we add together? We added 3. Now, how accurate is your answer compared to using a ruler and a protractor? Way more accurate.
Because there's no human flaw.
There's no that plus or minus 3 degrees kind of stuff, right?
Yeah.
Yeah. So, you feeling good about that?
Sure.
Okay. One thing I like to do is write down the steps. Go back. So what are the vector addition steps? They are, step 1, find all the x components, find all the y components. I like x, y, x, y, x, y. If you want to do all the x's first in the column, go right ahead. Then do all the y's, I don't care. Find the x and the y's. Then what's the next step?
Add all x components.
How'd you know?
Because I wrote it down.
Oh. Add all x components. Add all y components.
How fast do you think I write here?
Can you just like open it?
Yeah.
Just write it.
I just.
What's step 4? Step 4 is use Pythagoras and add all the x and y components, right? rx squared plus ry squared is r squared. And then last step, find the angle. No, it's not enough.
Or yeah.
Damn, I'm gonna cap it up.
That was way out. That was right.
Okay, so I got my x and y components. My x components, I got 1.48, 0, 1.35. My y components, I got minus 1.76, a plus 1.8, and a plus 1.6.
I have a question.
Okay.
Why did you put in the V3? Why did you put 50 there?
Yeah.
Is that not the angle?
I would put it at the top.
East 50 north. East 50 north.
Wait, why am my x's and y's are opposite?
You're going east first and then 50 to the north. So you got to do it down there. East and then north, right? Okay, and then I just draw a line like that, and then I would say something like Rx is equal, I show the addition, so 1.48 plus 0 plus 1.35 2.83. And ry is going to be minus 1.76 plus 1.8 plus 1.6. Ah. $1.64. And then what do? Combine them together, draw that picture.
Yeah, that's the one thing that I have.
Okay, well, this is Rx, and I didn't actually explain this, so that's a good point, I should do this. Rx is 2.83 and it's positive, so that's going to be to the right, right? 2.83, and the Ry is 1.64, so that's positive, so it's going to be up, and there you go.
Is it always gonna look like that?
Always going to be to the right and up?
Yeah.
No, because if this was negative, it would be to the right and then down, right?
It'll always be a right angle.
It'll always be a right angle. It has to be, because X's and Y's are right angles to each other. That's the whole point, is that you get that right angle at the end.
Why?
Right? This would be called R. So R squared is going to be 2.83 squared plus 1.64 squared.
I did not get the same calculations.
Are we doing this? No.
I'm just gonna.
Actually, subtraction breeze.
Is it a?
Yeah, it is.
Oh, never mind.
This is going to be, what is this unit? I don't even know. Kilometers an hour?
Yeah.
We'll get to that. Don't worry about subtraction. And you got to have the angle, right? So opposite over adjacent, so that's going to be 1.64 over 2.83. So second function tan, bracket, 1.64 divided by 2.83. I get 30 degrees. So east, 30, north.
I switched up the X and Y.
The question is, why do we put theta in this corner and not that corner? Because that's where we started, right? See, the arrow goes that way and then up way, right? So it has to be where you started.
I just need a lot more practice.
You need practice. Okay, so you've got a little booklet there. I should just explain what's in there. You see George. Where's the other one? Oh, perfect. Okay, so in the booklet, you guys, I gave you lots of stuff here. I will say this, the people that made this didn't leave you enough room. Josh, you listening? Okay, so there's not a lot of room here. I apologize. I just didn't bother pulling it apart and making it better. Okay, so on the first page, all you got to do is find components. You don't add. You just find components. No adding. Just which part?
Finding components.
Just, like, all you got to do, like, just this. That's all you're doing. Okay, I've had kids before try to add these all up. They're different. They're A, they're B, they're even different units. You're just finding components. Okay? The next page. Vector addition by components. You have to add them. Here's where they stop giving you enough room. Okay, you have to add that on the second page. Then the next one, vectors in two dimensions. It's exactly the same thing, there's just more of them. Again, not enough room. I'll get to that page. Okay? There's a QR code there with all of these done for you, because these don't have answers, so to get the answers you actually have to scan or go to School of Gene Finder. Okay? Then there is a vector hand-in, so you can pull that back one off. At some point before the test, I would like this back. Tomorrow's Wednesday.
Aren't you gone for that?
I'm on Friday. I got to do vector subtraction, and I got to do relative motion. Vector subtraction is pretty easy. It won't take you the whole period like it did today. So I'll give you like the second half to work with. AJ.
That was my question. You're doing vector subtraction?